Hello. I miss you guys today. So this is the answer key video, like a solutions video to the 6.1, 6.2 quiz study guide. So I'm going to go over most of these. There's a few of them that I might just kind of like let you finish on them and give you the overall explanation to these. Before I start though, I want to make sure if I helped you with something yesterday, and like I maybe explain it differently today. I changed some of the wording on some of these problems to be more specific. I realized yesterday, as some of my classes went on, students were interpreting the problems a little bit differently than others. And the way that you solve some of these, especially when you're talking about combinations, is all going to be dealt with based on how you're interpreting the problem. So I was a little too non-specific yesterday when I worded some of these. So I changed some of the wording on them to make them very much more specific and not open to interpretation. But if I said that yours was correct yesterday, I would accept that still on a quiz. So I just want you to make sure that you understand that. I will still accept that. And as long as I can see your thought process. So before we even get started, I just want to make sure that you know tomorrow that you need to be putting these kinds of things onto your paper. Can't think of the word. So I know that you will type these into your calculator and get an actual answer out for me, but I want to know what your thought process was. So this is like the only work you can show me for these, and that's fine, but make sure you are showing me that work so that I know when I'm going through them what your thought process was, and you can pretty much still get all the points if your thought process was correct and if the way you went about it was correct. These are really tough and they're really open to interpretation. And as much as you make the wording super specific, it'll be really easy to get sidetracked or maybe slip up and not think of something. And I just want to know what your thought process was. That's what's more important to me. So if you can show me that and I can understand it, if you even need to make notes off to the side for me to say, like, this is why I did this, because I know I won't be here. That's fine. I will also take those and I will take those all into account when I'm grading. Okay. Just want to make that clear. So these first couple ones are so calculator based. I'll put plenty of these on here just so that you can go through them and get some nice points. But these top ones, I just want to remind you, when you want to go put something like 8, choose 4 into your calculator, you need to go to the math button, scroll over. It's either going to be PROB or just PRB. From there, you go down to where you see NCR. You hit enter on it. You'll come up into a little box and then C and then a little box. Wow, I can't draw a box. And you use your arrow keys to put your 8 and then your 4 in, hit enter, and you should be getting 70. Okay, the only other one I want to talk about then is the very last one that is in these parentheses, 9/8. So when you see something like this, it's just a different notation, not as much of a common notation, not one you're going to see me use often, but one that I want to make sure that you know is representative of a combination. And if you saw like an SAT or something else, or you're going to another stats class in college, you'll be like, oh my gosh, yeah, I remember that. I know that. That's a combination. You will generally see it like this. This is just another way that you could see it. When you go to put this in your calculator, you can put it into familiar notation, which would be 9, choose 8. Top number goes to this side, bottom number goes to that side in that calculator, okay? And that value would be 9. You put that into your calculator. All right, let's move on to some of these next ones. So number 2 is saying how many possible starting lineups can a coach make for basketball? So again, I put in there that 5 players total are on a starting lineup. So you know, if you don't know basketball, you still have that piece of information for you. And this is when they have 17 total people on the team. So remember, when we do NCR, N is total number, R is what you're choosing of that total number. So if I'm scanning through here and N should be the bigger number, I see 2 numbers. One number is 17, the other number is 5. Total people on the team is 17. So that's going to be my N. I'm going to choose just 5 of them for my starting lineup. Okay, so 17, choose 5. which should be getting you about 6,188. Okay, I won't solve all these for you, but I will make sure you're on the right track with some of these. Okay, I don't need to erase that. This was number 2. So number 3 then is asking how many passwords are possible for a 6-digit iPhone password. So let's think about this. If my 6-digit iPhone password was 1, 2, 3, 4, 5, 6. Okay, and this was my correct password. If I went and put 6, 5, 4, 3, 2, 1 into my calculator, into my iPhone, is that going to unlock my phone? No, you have to have the order correct. But the issue is, in combinations, order does not matter. So because of order not mattering with combinations, every digit is a separate event, okay? The way combinations work is they pull all the different kind of numbers into one whole basket. So they would say, yeah, you can take all 6 of these numbers, and then that is one combination. And they would say, it doesn't matter what order they're in, but I have all 6 of these numbers in a basket, like that's a combination. Okay, dump it. That was one time. So they would not pull these numbers in this order. They would not pull them in a 6, 4, 5, 3, 2, 1. Okay, they're not focusing on order. They're just saying, how many numbers can we pull at one time, regardless of what they're in? Okay, dump them. Now let's pull some different numbers and then some different numbers. So that number is still going to be very large, but it's not going to be correct. Because in my password, I have to know that order matters here. So when I'm going through, digit 1 of this password is its own combination, its own event, okay? Every time you make a choice, I say you have to do a combination. Well, you have to choose what's your first digit gonna be, what's your second digit, what's your third, fourth, fifth, and sixth. It's a choice every time. Okay, so we have a different combination every single time. Now is to say, well, what's my options? How many different total numbers can I choose from? So we can choose any number that's a single digit number. And 0 is not off the table, right? I'm sure some of you probably have 0 in your iPhone password. So between 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, be super careful. That was 10 digits. Everyone's gonna want to say 9 because 0 through 9, it's actually 10 digits. So 10 is the total digits or total numbers you can choose from every single digit of this password. We're not saying that you can't repeat, so it doesn't matter. Those same 10 numbers are back up on the table every single time. Every time though, you're only going to choose one of them to put into each digit. I can't choose 2 digits to go into this one spot. Okay. Lastly, what kind of operation has to go in between these? So think about it's either going to be multiplication or addition. So it will be an and or an or. If I said my password was 1 or 2 or 3 or 4 or 5 or 6, is that insinuating it's an entire password or it's possibly 6 different passwords? Or is insinuating that it's 6 different passwords? If I say my password is 1 and 2 and 3 and 4 and 5 and 6, that's saying, okay, all those numbers are included, which all 6 of these numbers need to be included. Meaning I have to have an and in between, which is multiplication. Okay, so multiplication in between all of these. You calculate that up, you will get 1 million. 1 million different passwords you can make out of a 6-digit password. All right, let's keep on moving. The next one has everything to do with cards. So I'm going to make a better description on the actual quiz. If we're dealing with cards, I will put more clear and concise things about cards. I try to overload the directions with all the different ways that you can deal with cards and that what kind of suits they have, how many cards are in a suit. And I think I overwhelmed people a little bit. So the first question is, how many different 5-card hands can you make that have 1 queen and 4 other cards? So thinking about, and so the one wording I added in here is that I don't want queens. Okay, so how many different 5-card hands can I make that have 1 queen and 4 other cards that aren't queens? So what I'm thinking, I know I have to have 5 total cards in the end. 5 is not my end. It's not the number I'm starting with. It's how many I need to end with in the very end of this. So if I have to ensure I pull 1 queen, do I want the whole deck in my hand? If I only want to pull 1 queen, I have to ensure that when I do pull out this deck, that there's a queen that I pull out. So if I have to ensure that, I can only have queens in my hand that I'm going to pull from. There's 4 queens in a deck, so I have to have 4 total queens in my hand. I'm only going to pick out 1 of them. Okay? That gives me my 1 queen. Now I have to figure out, how do I get 4 other cards that are not queens? So the word and comes up, which means I'm going to multiply. 4 other cards that aren't queens means queens have to be taken out of my deck. If I have the whole deck in my hands, there's a possibility when I pull 4, I pull a queen. So all the queens have to be removed. If I remove 4 queens from a 52-card deck, that leaves me with 48 total cards. And I need to choose 4 more of them, okay? I've had a couple people ask me, where's the 5 come in? Like, there's a 5 in this story problem. Where's the 5 come in? Your number that you chose should add up to 5, okay? Because you want to have a 5-card hand. If this combination, you chose 1 of those cards, okay? I have 1 in my hand. Now I chose 4 of them. I now have totally 5 in my hand. So we want to ensure that when we're pulling those, we don't use 5 as outside numbers, but this is what those 2 numbers should add up to. All right. And again, go ahead and put that into your calculator. Next one, how many different 3-card hands can you make that are all spades or all diamonds? So spades and diamonds. I did put up there that there's 13 cards in every suit. I think I forgot to mention though how many or what kind of suits there are. So spades, diamonds, clubs, and hearts. That's what it is. Spades, diamonds, clubs, and hearts are all suits in this deck. So spades has 13 of its own cards. Diamonds has 13 of its own cards. Because we're saying how many combinations can you have of 3 diamonds or 3 spades, we're going to keep these separate. I know I'm going to have addition in between. There's 2 different combinations. Both of these have the same total amount, right? So I have 13 total here, 13 total here. I'm also choosing 3 every time, so I'm going to add that up to 3. But this gets a little bit more tricky because I said, well, your numbers in the end should add up to the kind of hand you're having. Because this is or, if there's an addition sign, this is my 3-card hand, or this is my 3-card hand. That's why we have to choose 3 there. So you cannot add up there. All right, now I want you to put that in your calculator then to get a final answer. Okay, so these bottom ones is where it starts to get a little bit tricky. And very truthfully, I'm going to tell you right now that I will not be putting an at most or an at least on the actual quiz. I think those were 2 that I wanted you to see on this study guide, but wasn't something that I actually want to go ahead and test you on. They're tricky and they really get your mind thinking a lot, which is what I wanted. And I'm not going to go ahead and put those on that quiz though. So if those were 2 that you want to talk about further, that explanation is a lot better in person. So I'm going to have you come in person. I can kind of go over that with you. All right. So for the very last one, how many 5-card hands can you make that have 1 3, 1 5, and 3 other cards? So in this case, I am going to explain this in the way that those 3 other cards are different. So they're not a 1 and they are not a 3 and they are not a 5. Okay, stipulations, I need to have 1 3, 1 5, 3 different. And I'm explaining this as in those other 3 cards are not 5s and not threes. Okay, so every single card has 4 of a kind in the deck. So I have 4 threes total, choosing 1. And multiplication, right? These are all going in the deck together. 4 total 5s, you're choosing 1. And now how many other total cards am I having? I know I have to choose 3, right? 1, 2, 3, 4, 5. Now I have to figure out how many cards do I have to choose from now. I'm asking you to take out your 5s and your 3s because I sent 3 different cards, not 5s or 3s. Taking away, okay, my whole deck of 52, I take away 4 3s. Those are gone. Now I take away 4 5s. Those are gone. I've taken away 8 total cards, meaning, right, if you subtract just those 3s, now I'm down to 48. Subtract just those 5s, I'm down to 44. So it becomes 44. Choose 3. Specifically because I said different cards that are not 5s or 3s. Okay, and again, calculate that in your calculator. Okay, but make sure on that test that you're showing this part of your work. I do want to see the final answer, and make sure you're showing that part of your work. On the back side is your probability distribution. Not probability, binomial distribution. So that formula I'm going to talk about really quick is P of K equals N CK times P to the K times 1 minus P to the N minus K. Right, so in here, N is still total number. Okay, and this can be a wide range of things. It can be total number of trials, total number of things you're doing in that experiment. Like, it's going to be a wide different range of specific wordings. We're saying total number. What's the total number? K is possible outcomes. So K is that number that's changing every single time. K determines how many formulas we have to calculate with this. If the possible outcomes are 1 through 2, you have to calculate when K is 0, or sorry, if the possible outcomes are 0 through 2 for K, then you would say when K equals 0, what's this whole thing equal? When K equals 1, what's this whole thing equal? When K is 2, what's the whole thing equal? And then you'd be done. If it was K through 20, or 0 through 20, you'd have to do 0, 1, 2, 3, 4, 5, 6, all the way up to 20, so it'd be a mess. Okay, P is probability of success. Okay, so it's going to be represented in a percentage. You have to make it into a decimal. This is probability of failure. If you must know, but again, if you have that probability of success, you can just 1 minus that and you will get that probability of failure. Okay, so in this first equation, or first problem number 5, we have you perform a binomial experiment consisting of 10 trials with a probability of success of 36% on each trial. What is the most likely number of successes within the experiment? So numbers I'm picking out, and that we are going to be doing 10 total trials. 10 is the total number then. So here, I'm going to have 10. Probability of success is a 36% on each trial. So here we said 36% will be represented as a percentage. I have to make this into a decimal, which would be 0.36. Probability of failure, if I take 1 minus that, it'd be 0.64. The only other thing I need to deal with is my K value. So if I go into 10 different trials, I have the option or the possibility of saying 6 of those might be a success. 4 of them might be a success. 7 of them might be a success. All 10 might be a success, and none of them could be successful. So I range from having none successful all the way up to possibly having all 10 successful, meaning K has to equal 0 to 10. So that's 11 total things that you have to calculate here. Okay, 11 total probabilities. You have to do P of 0, all the way down to P of 10. Okay, setting up P of 0, I'm substituting in 0 for K. So I would have 10 choose 0 times 0.36, again, putting all these numbers from what we just explained, to the 0 power, because I'm replacing K with 0, times 0.64 to the 10 minus 0. Okay, and then you would hit enter. You should get a decimal of like 0.012. It would be like 0.0115 or 0.116. So you can round that up to just 0.12. Okay. Instead of typing this whole thing into your calculator again, I reminded you guys, there's something when you do second entry. So second equals, it will pop back up what you just put in before. It'll pop this whole thing back up because P of 1, all you have to do is go replace every 0 with 1. Replace 0 with 1. Replace 0 with 1. And then calculate that one again. Okay? So the way to solve this, right? They asked us, what is the most likely number of successes within the experiment? So what you're looking for is the highest decimal. Okay, you calculate all of these out. And if you are like starting to get a super low number, you can kind of say like, wow, it's definitely not going to be 10. I'm going downhill. You can start inferencing and saying, well, okay, I think in this case, it's 3, right? You start tapping out after 3 and you plateau and come back down. So if 3 was our highest, and again, I think P of 3 equaled, and I should mention this on the quiz, I don't need you writing this whole thing out. I need you saying P of 0 equaled this. P of 1 equaled 0.077. P of 3 was, oh, wrong one. 0.65. P of 3, though, equaled 0.246. And P of 4 was 0.242. Okay, so I peaked here at 3, meaning 3 is my highest probability of an outcome. 3 is what's most likely going to be my successful number of trials. Looking for the highest decimal is P of 3, saying, yep, this is my highest decimal, meaning it's my highest probability of success. So in this case, it would be your 3 successful outcomes would be your highest. Okay, leading us to the very last one. All right, so this one is not asking you to do what you did this last time. You still have to use this formula. This is asking for one specific probability. So let's read the directions. I don't know how to say his name, but he's of the Sacramento Kings, and he made 92.7% of his free throw attempts in 2003-2004 NBA regular season. What is the probability that he will make exactly 14 of his next 15 free throws? They're not asking you what's his, how many will he most likely make. They're saying, we want to know what's the probability he'll actually make 14. So you have to focus on just 14. So there's 0 to 15 possible outcomes. You are specifically saying, nope, I only need to find out what happens at that 14th free throw, okay? I only need to know that. So total number, I'm still shooting 15. I just need to know what happens at 14 though. My probability of success is 0.927. 927. Okay, so the probability of failure, 0.073. Yeah, there we go. 0.073. So you need to fill this in and say P of 14 is 15, C 14 with 0.927 to the 14th, 0.073 to the 15 minus 14. I believe you got about a 74.6% chance because this decimal was fifth. I would put that back into a percentage. Okay. All right. So remember, no at least or at most on this quiz. Or if you have any questions, please reach out to me. I will be available all day and all night Wednesday, and I am also going to be available Thursday on that quiz day. So I have appointments, so if I don't respond immediately, like understand it's just because I'm at an appointment or something. Well, good luck.